Okay, let's do this problem. Determine the limiting reactant and the mass of nitrogen that can be formed from 50 grams of N2O4 and 45 grams of N2H4. And then I give some molar masses so we don't have to totally look those up at the moment. Okay, so let's go ahead and start this. So how I do it is I write down what I know. I have 50.0 grams of N2O4, and we're trying to find out how much nitrogen can be formed here, so that'd be N2. And down here I'm going to do my other one. I start off with 45.0 grams of N2H4. That's an N, N2H4. Okay, remember, limiting reactant means that I have two quantities, and whichever of those two quantities of reactants produces the least amount of the product, then that is going to be my limiting reactant. That's the one that when I react the two runs out first. And we can never tell just by looking at grams. So we need to run through the stoichiometry here. So I know, because it's given to me, that there are 92.02 grams in 1 mole of N2O4. And I know that for every 1 mole of N2O4, I make 3 moles of nitrogen. So every 1 mole of N2O4, the stoichiometry says I make 3 moles of N2. And then we asked for it actually in grams, and so that I know that for every 1 mole of N2, there are going to be 28 grams of N2. So my grams of N2 will cancel out. My moles of N2O4 will cancel out. My moles of N2 will cancel out, and I'm left with grams of N2. And so we can end up doing those calculations right there. Let's set up the next one, then we'll do the calculation. So I'm doing N2H4 here. And so I need to convert that into moles. We don't ever deal with grams. I see so many people just go with grams and they don't convert those to moles. So the strategy is convert to moles and then do the stoichiometry. So I know that there are 32.05 grams in 1 mole of N2H4. I get that from right there. I actually give that to us. Okay, and then we do the stoichiometry. I know that for every 2 moles of N2H4, I produce 3 moles of nitrogen gas. And so I know that for every 2 moles of N2H4, I produce 3 moles of N2. And then again, we want this in grams, so for every 1 mole of N2, I make 28 grams of N2. So my grams of N2H4 will cancel out. My moles of N2H4 will cancel out. My moles of N2 will cancel out, and I'm left with grams of N2. So I'm going to quickly do this on my calculator I have here. And if you want to follow along, so how I put it in my calculator, so that'd be 50 divided by 92.02 times 3 times 28. And so when I do that, I am left with 45. And let's get the right number of sig figs here. There's going to be 3 sig figs based on here and here. And so it's going to be 45.6 grams. Let's do the bottom one. So I have 45 divided by 32.05 times 3 divided by 2 times 28, and that is going to equal 58.9, or actually 59.0. So 59.0, 45.6 grams. My limiting reagent is the 50 grams of N2O4. Make sure you know how to do this. These aren't that difficult. But remember, if you start with grams, convert to moles, do your stoichiometry, and then convert to grams if you want to. We could have stopped right there, but the problem asked for this in grams of nitrogen. That's how you do a limiting reagent problem.